Hello and welcome back. Today we'll be going through a number of exponential functions and their graphs. Okay, so we're going to be drawing them basically using Desmos. I use Desmos a lot for the past 2 years, and I really like them. And only recently I found out that they have a desktop version. I always use the Android app, but I think they have an iOS app and an Android app, and also they have the web browser that you can use on any device. So I used the web version over here. Okay, so let's actually start by graphing 2 raised to the power x. Okay, so what we're actually going to be doing here is spanning a whole lot of exponential functions over here, and generally looking at what changes visually when you change a portion of the base first of all, and then we're going to be changing the independent variable part of it, and going to actually see how the things change. Okay, so this is what 2 raised to the power x looks like. Now let's increase the base. This is 4 raised to the power x, and as you can see, it became a lot steeper. It's like a hill, and it looks like we're at the bottom of the hill, and it just got a lot harder to climb the hill. And 16 raised to the power x, let's see, it becomes a lot harder, it becomes a lot steeper, and as you move forward, 160, see, it becomes actually a lot harder. And as we increase the base, what you can actually see is it almost becomes, if you're trying to climb this mountain, it is going to be really hard. Okay, but as you can actually see, the base portion of it is starting to really touch the x-axis, and the upper portion is really starting to come close to the y-axis over here as you increase the base. Now, yes, let's look at the number line. We have covered the white portion over here, and we're left with the portion from 0 to 1. Remember, the base cannot be less than 0. Okay, now let's go through this portion. We have 0.5 raised to the power x. Now we're going to be dividing this in two portions. First of all, we're going to be going up from here, 0.5 to 0.999, close to 0.1, close to 1, but not reaching 1, because remember, we can't have 1. Okay, so as you can see, we are slowly starting to make this into a really straight line. See, 0.99x is almost straight. Now let's go through the numbers 0.5 to almost 0. Now, as you can see, it looks like the mountain, we're on the other side of the mountain, and it's starting to really become steep and hard to climb, and the upper portion is starting to touch the y-axis, and the lower portion is like the neck portion over it. If you can actually see this portion, it is starting to go to the point 0, 0, and yes, it has really started to become almost like a perpendicular angle, right? See, almost 90 degrees. Okay, so now let's actually try to change the independent variable and see what happens. Okay, and remember, it can have any value. It can be negative, it can be positive. Okay, so yeah, let's use this as our base. 0.5 is going to be our base, and an independent variable is going to be just x. Now let's invert this, and what happens is that when you put a negative onto the x, it just becomes inverted. Whatever we have previously, it becomes an inversion of it, as if you have like a inversion mirror on the y-axis. Okay, so let's move forward, and as you can actually see right over here, 2 raised to the power x has the same graph as this one, even though they're actually pretty different, right? This is 0.5 raised to the power negative x, and this is 2 raised to the power x. But in fact, you can actually find out that these are actually equivalent. See, and even the graphs look pretty equal. Now, same stuff. we put a, instead of just the x, we put a negative x, and the thing just becomes inverted. Like everything that was on the right side becomes part of the left side, and vice versa. See, and this is actually similar to what 0.5 raised to the power x looks like. And similarly, they are actually equivalent if you try to do some algebraic manipulation stuff, right? Okay, so let's actually try to increase the independent variable part. Now we have 1x. Now we have 10x. And now 100x. Now notice how the graph changes. It starts to become a lot like a 90-degree angle over here, and it just starts to like the slopey upper portion is starting to touch the y-axis, and the bottom portion just starts to touch the x-axis. And okay, so we'll actually try to decrease the independent variable this time. We have 1x, and we're going to decrease 0.5x, 1x. Okay, so this is actually 0.1x. Okay, so let's go back a little bit. This is 0.5x. This is 0.1x. And similarly, we're going to looking at 1x and going to decrease this. This is 0.5x. This is 0.1x. So actually, you can see that it actually just flattens out on both sides. Okay. Okay. My bad. I just actually accidentally pushed the pause button over here. So this is the actual last portion that we have to cover. Now 1 raised to the power x is going to be just a straight line. No matter what the value of x is, it just stays a straight line, which passes through 1, 0, 1. Okay, so that is it. Hope you learned something.